Well, hello everyone. Welcome to Modern Trade Communications webinar series. I'm Paul Deffenbaugh. I'm the editorial director at Modern Trade, and we're the publishers of Metal Architecture Magazine and Metal Construction News Magazine. Today we're presenting the How to Specify MCM panels as part of our webinar series, and we're glad you joined us. Before I turn things over to our two panelists, I want to take care of a couple of the housekeeping things we got to do here. We do have a lot of material here, and I think you're really going to enjoy this discussion between our panelists. I encourage you to submit questions on the window on your screen. We'll try to get around to those, and I'll monitor the questions and raise them at the appropriate time. We do provide a copy of the presentation. You'll get an email tomorrow as a follow-up to this that has a link to that presentation and also has a link to how you submit information for your AIA CEUs or if you just need a certification, how we take care of that stuff. All of that will come to tomorrow, and it'll come to me, but feel free to contact me at any time if you have any questions. You'll see my address on the email that went out on this. We are very happy today that Firestone Building Products is sponsoring this webinar. They are great supporters of education in the construction industry, and especially here in our niche in the metal construction industry, and encourage all of you to look into their products, become familiar with them, and support them as they are supporting us. This slide is one of the requirements. We're talking best practices here. We're registered providers of AIA, and this slide goes through all of that necessary information. You can download that copy if you need it as well. And this is another required slide. It summarizes the course that we're doing here, which is also the summary on the AIA website, the CES website. And you'll be able to see all of this stuff in the download. Mainly what we're talking about here today is best practices in specifying metal composite material panels, MCM panels. And we're going to get into a little bit about some of the changes in the National Fire Protection Association's 285 standard and some of the stuff that's happening with continuous insulation. But that's what the course is about. And the learning objectives identify those areas that I just kind of outlined in the description, and this is what you're going to learn as we go forward. So these are our two presenters today. They're incredibly knowledgeable in the area. Since we're discussion-oriented today, I want to do the introductions for both of them at the top rather than interrupt the presentations later. Zeke Miller is president of Miller Clapperton. He came up through the industry. He started as a summer worker running the chop saw operation at Miller Clapperton shop, and he did that for a few months, and then he got moved indoors to help and support, and then after that he began helping out with panel takeoffs, material takeoffs under the supervision of Dave Clapperton. It wasn't long before he was handling the majority of the estimating duties and preparing prices and quotes for Miller Clapperton, and then in '98 Zeke was named sales manager. That's a title he still holds today. And in May of 2001, Miller Clapperton began to execute its succession plan, and Zeke was promoted to president. And he's in this position. He's responsible for all day-to-day business decisions and reports to the board of directors. Our other presenter here today is Eric Sassak, who has been a member of SmithGroup JJR's building technology studio for over 5 years. Eric's based out of their Detroit office. He has a holistic and definitive approach to building technology, and he's been heavily involved in design and development of contract documents for complex projects. Eric takes time. He carefully analyzes building materials. He adheres to distinct project details, and he meets client expectations on all the projects he's involved in. His project responsibilities include coalescing the different specialties of the building technology studio into a unified set of construction documents, integration of detailing to best accomplish both technical and aesthetic design goals, field analysis, and construction administration. Eric's a board member of the Eastern Great Lakes chapter of the Association for Preservation Technology International, and he's keenly interested in bringing state-of-the-art building technology solutions to historic buildings in a way that is sensitive both to the preservation of the architectural heritage and the needs and requirements of modern building function. So that's Zeke and Eric. We're thrilled to have both of you guys on board here. Let me get started here with the first section of this. We're dividing this into 3 sections, and we're going to do section 1 on the best practices. And we're going to begin with Zeke, who's going to describe the 7-step approach to specifying that Miller Clapperton takes. So Zeke, I got you keyed up on the first slide for you here. Take it away.
Okay, well, I appreciate the opportunity, Paul, and the opportunity to co-present with Eric on this. So we are a fabricator of MCM panels, and for those that are not familiar, MCM is the latest term that an older product, ACM, is being called. And the reason why it's called MCM now is because they've introduced new skin types to the composite material world in lieu of just aluminum. So when you're specifying an MCM project, the first thing you need to do is to select a sheet manufacturer. And there are 4 domestically produced MCM sheet manufacturers that are produced in a continuous process, meaning they're not batch produced, much like you would build a sandwich where you put a skin, an adhesive, a core, an adhesive, and a skin on it. So all of the 4 manufacturers that you see listed on the screen are domestically produced in a continuous process, and those are the product names are Alpolic, manufactured by Mitsubishi Plastics, Lucabond by 3A Composites, Larson by Alucoil North America, and Renabond by Alcoa Architectural Products. Now, there are some other people in the industry that are presented as manufacturers, but those companies are actually systems providers, and they're private labeling one of these 4 companies. And the good news is that all of these products are high quality and should be considered equals in all cases. So it's important that you don't just specify 1 or 2 of these guys, because each one of them have their own niche as far as what they are good at. One of them might be good at a natural metal composite like a zinc or a copper. Another one might be good at small quantity custom colors. So it's important to always specify all 4 manufacturers. Next slide, please. And feel free to ask some questions along the way through the chat box, I guess. The second step is, in addition to the sheet manufacturers, another important part of your specification should be the fabricator requirements. The sheet manufacturers, all they provide is a sheet of material on a skid for somebody to work their magic with and fold it and bend it into your job site specific size and condition. So the only difference between a guy that's able to fabricate these great sheets of material in his garage and a high-rise office building is your specification requirements. So it's incredibly important. Some things that I would suggest putting in your spec to try to keep the guys that are less sophisticated and possibly not providing tested attachment systems is you need to try to specify somebody that fabricates a minimum of 150,000 square feet per year. This will allow you to get a professional, not just a tradesman that is doing this just for this job because the general contractor wanted it in his package. So that's a good requirement. The next is specify a fabricator that's been in business under its current name for a minimum of 5 years. And I specifically mention that because there are a lot of guys that do a bad job of fabricating a great material, and if they can't do it, if they can't keep the same name for 5 years, you probably don't want them on your job. The third thing is specify that the majority of the fabrication process be done in a shop environment. This will prevent people from having sheets of material shipped to the job site and then putting it on sawhorses and cutting the panels to size and routing them right there on the job site. You know, there's never been a job site that isn't too wet, too dirty, too hot, too cold. It's definitely too everything to fabricate on site. There will be panels, end panels, fill-in panels, or whatever that you will have to fabricate on site just to maintain the schedule, but the majority of them should be done in a controlled shop environment. Specify that a fabricator have tested attachment systems in their own name and dated within the last 10 years. There's a lot of things happening in the industry, and the industry has really evolved in the past 10 years, and oftentimes the material manufacturers will have a blanket test that they have performed with attachment extrusions, and they will sell or allow fabricators to copy these extrusions. But what oftentimes doesn't happen is that these fabricators don't go through the entire, don't take all the steps that that was used in the tested attachment systems, as far as silicone behind extrusions, corner clips, lots of other parts and pieces that were used in the test that was performed by the manufacturer. They'll try to shortcut it, possibly out of ignorance, possibly out of intent, but make sure you specify that. And lastly, when in doubt, when you want to see the best MCM panel specification, you can always go to the Metal Construction Association website. There's a group of premier or premium certified fabricators that, along with the manufacturers, have worked on the best specification in the industry for over 2 years, and it has been recently completed. This specification takes into consideration all of the things listed above, as well as many other important things to ensure that you get the best fabricator on your project, and it's not necessarily the most expensive fabricator. These guys are still delivering a great value while maintaining the industry's highest standards. So next slide, please. Attachment systems. There's really two types of attachment systems. There's one attachment system that's referred to the industry called a wet seal, and it's a caulk joint. And it's kind of counterintuitive, but the wet seal is a caulk joint, and there's the applicable test. And then you have a dry seal, which just means there's no caulk in the joint, and there's 3 different variations of that. There's a drain back ventilated rain screen, there's a pressure equalized rain screen, and there's a route and return dry gasket that, just like the wet seal attachment system, it is a barrier system where air and water are stopping at the panel face, whereas the drain back ventilated and the pressure equalized attachment system, air and water are allowed to move freely or semi-freely through the panel joint within the panel system. So those are your 2 big choices: wet seal, dry seal, and then what type of dry seal. Next slide, please. Choosing a material thickness, and this is one of the biggest choices you can make right here. You have 2 what I would call industry standard architectural panel thicknesses. There's 4 millimeter and 6 millimeter. 4 millimeter is what I would call the industry standard thickness. It's readily available. It's usually stocked in many different standard colors. It's stronger than 6 millimeter thickness tensile, shear, and flexure, as well as it's easier to fabricate compared to the 6 millimeter panel thickness. Then you have 6 millimeter. 6 millimeter is priced at a premium by the manufacturers. It requires a minimum square foot order, and it requires significant setup charges for quantities less than 10,000 square feet. And obviously it's not as strong as 4 millimeter in tensile, shear, and flexure. And then increased structural properties are marginal for the increased cost. Now, if you take anything away from this today, and I hope you take a lot of things, take away that 4 millimeter is the way you need to go. There's really no advantage to the increasing the thickness of the material. The panel face deflection and perimeter structural framing deflection of your panel is being taken up in the attachment system and not the thickness of the material. So stick with 4 millimeter. You'll have many different options as far as a smaller quantity being more affordable because the material is stocked rather than everything having to be a custom run. Next slide, please. Choosing your core of material. This is an important one, and there's a lot of different things going on within the industry, and there's a lot of gray area on this as well. There's two specific types of panel cores. You have the polyethylene core, which is your typical core inventoried in stock by most manufacturers. And then you have the fire retardant core, and it is a core that can be used where NFPA 285 is applicable. And as a general rule, it's about $1.50 a square foot premium over the polyethylene core. In general, the polyethylene core is used when NFPA 285 is not required and the product is used under a 40-foot mean grade level. Now, there are some exceptions to that 40-foot rule, but they are very small exceptions and they're very confusing. So if you think, or if you have questions on that, I would definitely consult your authority having jurisdiction on that, because it is a super complex exception to the rule. Now, the fire retardant core is used when NFPA 285 is required, and then as a general rule, when the product is used over 40 feet mean grade level. Next slide, please. Color offerings. There's 4, we'll call them color families. You have standard colors, and standard colors are non-premium colors that are either inventoried or are priced without additional setup charges. Standard colors could be a 2-coat non-metallic, non-mica, like a white, a gray, a brown, or they could be 2-coat micas, or they could be 3-coat metallics. You have custom colors, and well, let me back up on the standard colors. Several of the manufacturers offer a large color palette in their standard brochures. The colors that are non-standard will still be priced in most instances like a custom color. So that brings us to a custom color. Any color that is not included above, and setup charges will apply to these colors. And what the manufacturers have to do is they have to paint enough coil that usually produces about 20,000 square feet of material, or they have some other minimum setup charges that you are paying for, either painted coil, wasted paint, lots of other things that make it more expensive. So if you have a project that's, say, under 5,000 square feet, it's pretty important that you stay in the standard color range rather than trying to go a custom color. Natural metals, and natural metals is the reason for the name of the product changing from to MCM from ACM. Natural metals include zinc, stainless steel, copper, and brushed aluminum. If you're thinking stainless steel, please consider brushed aluminum. It's a similar look, but the stainless steel has many, many fabrication problems associated with it. As a fabricator, it basically destroys your equipment, and you get minimal cutting and routing time per bit on your CNCs. The zinc, each manufacturer has their own zinc sheet or zinc coil manufacturer that they tend to work with. Some of them offer multiple zinc types, but one of them might be more affordable than the other. And on all these natural metals, make sure you consult the manufacturer and find out what the sheet widths are, because some of them are only available in 1 meter wide sheets, and you don't want to get too far in your design and realize that the sheet goods is only available in 1 meter when you've gotten everything designed around a 4-foot module or a 5-foot module. Specialty finishes, you're seeing a lot of these lately. The wood grains, the patinaed copper digitally printed look, the core tin panel look. There's just a lot of different specialty finishes that are popping up here of late. Next slide, please. Choose a finish. There's multiple finishes available. A 2-coat solid, your whites, your browns, your grays, large color selection and standard color palette. 2-coat micas, commonly used to match popular anodized color. The micas do not require a clear coat because the mica flakes do not oxidize, whereas in a metallic finish you have to have the clear coat because the metallic flakes will oxidize. You have to concern yourself with grain direction considerations, and it's approximately $1 a square foot premium over the 2-coat solids. 3-coat metallics require a clear coat because metallic flakes oxidize, as I mentioned before, and you also have grain direction considerations, and the metallics are approximately $1.50 a square foot premium over the 2-coat solids. The natural metals, again, consult your manufacturers on the sheet width rules, and then all natural metals are probably 100% increase in price over the 2-coat solids. Next slide. Eric,
thanks, Zeke. Do you want to wrap up at all on any before we pass it over to Eric?
Sure. Yeah, if you try to specifically focus on those 7 steps there, and it's very important for the fabricator because we have to know every single one of those to put together the most competitive price for you. Any gray area in any one of those could affect the price tremendously and also create confusion when a general contractor is getting a price from installing subcontractors. So if you just hit those 7 things, and most importantly, if you download the MCM Premium Certified Fabricator spec and start with that, you will get a better job and at a better value, I believe. So that's all I got. Thank y'all.
Thanks, Zeke. And just to reiterate that the metal spec for the MCM is on the Metal Construction Association website, which is metalconstruction.org. You can poke around there and find it. So Eric, let's kick off with you and talk a little bit more about the material from the architect's point of view. We got a real good sense of how the fabricators would like to see things work, and let's come from your side on this.
Thank you, Paul, and thank you, Zeke. I think you're going to hear that the architect side isn't too dramatically different from the fabricator, because in the end both of us want a happy client, and there are certain things that have to mesh in order to get that. Again, from the architect's side of this equation, our primary desire is to achieve the design that we've developed, and again, from the architect's perspective, it is something that it's better to understand the properties and limitations of this material during design rather than during construction, because that's when stuff goes into the weeds and you're really unhappy and the client gets unhappy and everybody gets unhappy and the project goes down the tubes. So really the key here is understanding the material. The first bullet there that says, know what it is and why you want it. I mean, it seems kind of obvious, but I think a lot of people just think that they want a metal facade and they don't give it enough thought, and so problems can arise from that. As Zeke pointed out, there are lots of good quality sheets out there that are available. It is important for the architect to do some research, even though they are there and they can be equals, because when you read the product data sheets, you might be able to find differences that will affect your product or your project. The good thing about this is there's a lot of different systems. They're available all over the place. But at the same time, I've got the note about the proprietary materials, and I can think of one product that actually is an 8mm thick panel, and it has an injected foam core, and it gets thrown out a lot of times with the 4mm panels, but this product is a very specific product, and it's available with some really kind of specialty finishes, and architects can get very drawn into, oh, I want this thing, but the problem is it's the only thing out there that's like it. And if you've got a client who needs to competitively bid and they're not willing to sole source, you're going to be in trouble, because what's going to happen is the architect will invariably put some of these other contractors, fabricators, and some of the other sheet goods alongside this 8mm product, and then they'll get the other thing and it won't have the specialty finish, and again, there's discord and unhappiness, and that's what we're trying to avoid. Obviously, if the client wants it, loves it, has to have it, and is willing to sole source it, great. But you have to understand that going in, because after it's bid is a bad time to figure it out. Next slide. So again, Zeke went into this. I'm going to go into it because it's really important, because we see it all the time in specifications. There's a difference between the sheet and the fabricated system. It's a stumbling point, and we need to get past it. And a good solution is to start with the spec section that Zeke pointed out. Even things are getting better within master spec and some of the commercially available specification systems that architects use. I've noticed that there have been improvements there, but some people are working off of old specification systems, and some of these old things can be in there. So it's really important that you have to understand the difference between your manufacturers of sheet and your fabricators of systems. It's a good way to start when you've got your sheets and now you got to figure out your fabricators, to look at the certified fabricators that are on the MCM website there. That is a good starting point. There's not a ton of them right now, and so you might have to supplement local ones. But if you do some pre-vetting and get to know these people, invite them into your office, get to see their systems, and follow the guidelines that Zeke put forward in terms of having a long-running track record and doing a volume of good work, you can get yourself to a situation where you've got an array of good qualified fabricators to put in your specifications. One thing you really need to do is avoid over-specifying, and you find yourself with situations where there are, again, elements in your spec that are proprietary to one fabricator or another. And again, going back to that spec section that was provided by Zeke is a good place to start. Next slide, please. Another issue is to avoid waste. I know that we get wound up, we want certain proportions. We want this module or that module on the facade of a building. And it's a valid argument. Design counts. It's an important quality. But at the same time, understand that these sheets are available in set widths and sometimes even set lengths. And you have to, when you're working with this, not just think about the face of the panel, but the returns. Sometimes you'll want a really deep reveal, and so you might actually have a 2-inch return leg on your panel. Well, when you unfold those legs top and bottom, that is a 4-inch additional amount of material on top of the overall height of the material. And again, if you're, say, I want a 60-inch face and I got 2 inches above and 2 inches below, you'll find yourself in trouble because nobody can fab that. So understand that you really need to keep in mind the face of your panel plus the return legs. You should always orient your sheets in the same direction. Sometimes, somebody will say, oh, I want to mix and match tall sheets with wide sheets. That's going to get you in trouble. Even on the solid colors, the way that the coil coating happens, you can get a certain way that the paint will lay, and you will get checkerboarding. It's especially an issue with micas and metallics, but I wouldn't bet my life on the solid colors either. It'll be less of an issue, but still, you won't be happy. Understand that if you're dealing with a project and you're fighting with value engineering, you don't want to be in a situation where the contractor is pointing out how much MCM you're throwing in the garbage because you didn't maximize your use on the sheet. Again, it's not something that is, a terrible thing and a moral thing for any of the architects to do to achieve their design, but the owner, the client, needs to understand this too. The last thing you want to do is, in the VE session, be made to look bad by, a contractor saying, well, look at this. We could have done this far more efficiently if you hadn't used the module you're using. If the client understands the issue and is bought in, it doesn't matter. It's what the client wants. It's all about communication, and if we don't do enough of it, that can lead to problems. So next slide. And remember, the reason for MCM, it really is it's to get the slick appearance of metal on the outside of a building while achieving larger panels than you could just with a piece of brake metal. The stiffness of the core of the MCM is key to the whole situation, and you see that from Zeke's presentation that the 4mm really does what you need it. There's going to be, depending upon the panel size, the fabricators put in stiffeners. There are different methodologies that can take care of problems, and that's another reason why you want a good MCA certified fabricator or a fabricator who is on par with them, because you want the people who know how to put the right stiffeners in and where to put them in and can actually engineer the product so that you can have a successful project. Sometimes, again, you get some well-intentioned folks who are a small-time operation. They might not have the sophistication to deal into these more detailed areas of the actual installation and design of the material. At the same time, don't oversell the capabilities of the material to the clients. What in the architectural world comes out perfect ever? There are so many times, and you could be in a situation where you've got a MCM panels going over a cast concrete frame, and just the construction tolerance of the concrete frame can cause issues with your MCM panels just because it's waving around. Those types of things can be dealt with in the field, but they really need to be, the owner's expectations also have to be in a proper place, and for them to think that they're going to get this highly machined, beautiful, perfect box isn't always achievable, and they should understand that. Next slide. So now we're going to go into this next section, and Zeke and I are just going to kind of play off each other on this. We're going to talk first about the fire issues. If you want to go to the next slide.
Yeah, I want to ask a couple of questions first because
Sure.
that are coming up. So I want both of you to weigh in on this, the issue of who do I contact to get information about what. And it kind of gets to, Eric, your comment about the idea of you have to understand the difference between the sheet and the fabricated system. If I'm talking the fabricated system, obviously I'm going to the fabricator. If I'm talking the sheet, I'm going to the manufacturer to find out information. But why, I mean, do I always go to the manufacturer, or do I just ask the fabricator to approach that? Who's the right person to work with most closely to get information on, you know, panel sizes? What size will this stuff come in? That sort of thing.
I would think the fabricator, because they deal with all the sheet manufacturers. So they know the limitations of, you know, say Larson sizes aren't quite the same as Alpolic. And, but they go to both of them. A lot of these fabricators will, you know, like Zeke pointed out, they bid the different materials against each other to get the best value for the project. And, but they'll be able to tell you that, again, your panel size is limited to this manufacturer or this group of manufacturers because in this case, this one doesn't fit that criteria. And the manufacturers are fairly synced up in terms of their panel sizes, but I actually went through their websites recently, and there is a little variation. So it is important to, especially for us architects, you know, we don't like looking stupid, and unfortunately when we get rushed, we do. And so, you know, we want to avoid being in that spot. And so doing a little bit of research up front saves a lot of headache in the future.
And Zeke, if you're working with an architect on a project, and then all of a sudden the architect's contacting the manufacturers directly, are you feeling like they're going around you, or is it? I mean, is that something you try to manage more closely? How's that situation work from your perspective?
No, I don't. We work hand in hand with the material manufacturers, and kind of the way we view it is, we want them to create the demand and drive the usage of the product. And once a designer decides that he wants to use MCM on a project, that's where we really can come in and sometimes help save a budget or keep a EIFS off a project versus using MCM, because oftentimes just moving a panel joint could make $5 a square foot difference in an installed cost, or combining two panels, or asking, hey, is this panel joint important to your design, or did you just put it there because you thought you were supposed to put it there? So I would agree with Eric that it's important to call the fabricators in, because we know what makes this product expensive and affordable, and can help direct the architect or the designer to get it for the best value. Whereas the material manufacturer, they know what their sheets cost per square foot selling it to a fabricator, and you know, their cost of their sheet goods is probably only 20% of your final installed cost. So fabricator is coordinating everything beyond a skid of material hitting his dock to be put on his machines.
And one other question before we jump into the fire NFPA issue. Zeke, you talked about kind of a fabricator. You should look for fabricators do a minimum 150,000 square feet and minimum time in business 5 years. And Eric, you mentioned that you want to pre-vet your fabricators, bring them to your office and talk to them. So I would assume that you're only bringing in people who kind of hit those table stake standards. What other kind of issues are you interested in with a fabricator? You know, obviously types of projects they've done, you know, reputation, that sort of thing. Are there particular areas you're asking about when you're pre-vetting?
Well, yeah, I mean, it really it comes to the history of their installations, we need to be able to see evidence that they've done good work. It's funny, we've had people come in and bring terrible desk samples, and when they do that, it's just like, how can we trust what you're going to do out in the field? You know, you got corners that are open and just look like, you know, bad, and you know, that kind of simple vetting is really important. It's just to understand the clip system, because there's little differences in how that's going to happen. And as we're going to get into some of the, briefly touch on some of the mounting strategies with continuous installation, that could inform our detailing, understanding how they clip back. They're all relatively similar, but there are some subtle differences, and it's important as architects that we make sure that we don't go down a road that can't be built. You know, those types of things really need to be considered, and again, to develop a rapport also, because again, we're going to be, every one of these situations is a custom hand-built product in the end. I know they've got, you know, the computer-controlled routers that, you know, cut the material, but in the end, it's a highly hand-constructed material. And so for us to be able to have a good way to dialogue with one another to address issues in the field, you know, we wanted curved panels or this or that, and be able to talk through the challenges that are encountered is really important, and not to have, you know, standoffish relationships from the get-go, because again, things won't go well.
Okay, excellent. Eric, let's jump forward into the MCM and the fire issue, and I've got the screen of the slide up now, and why don't you take it off, and you and Zeke can kind of cover this issue.
One thing again, just to throw it out here, we're not going to give a magic key to success here. Again, every project is different. Every project has a different authority having jurisdiction, and so it really is incumbent on the architects to go out there and understand the codes of the region or the city or the state that they're working in, and to interface with the authority having jurisdiction. There's nothing that can replace that, because again, the lack of communication is going to lead to trouble, pure and simple. And you might interpret a spec issue a certain way. One of those exceptions that Zeke was talking about, oh, I can go up to 50 if I do this, and the AHJ could say, no, not at all. And at that point, you're dead in the water, especially if you're all the way through CDs and you're, you know, in a situation where you're trying to get a permit. You want to attack these issues up front and early, and go through Chapter 14, Section 1407, that kind of rules it, and the international building codes and most state codes follow that as a template. That 8mm panel I talked about earlier, that will probably trigger the foam plastic core provision in Chapter 14. And so that would have a whole nother set of code issues that it has to conform to. So again, you got to understand your material. You got to look at your code. I'm not going to explain the code today because it's more than this hour can handle. You know, you have to keep in mind those 40-foot, 50-foot, 75-foot rules. Understand what having automated or automatic sprinkler systems does for your project. Getting the NFPA 285 test, or you know, some jurisdictions will allow for engineering judgments on that. Again, got to figure that out. You got to talk to people, find out what you need, and then get that information to them so you can have a smooth-moving project. Zeke, you want to jump in on any of this?
No, you're doing a great job on all the code stuff. This is where I would get in trouble.
I mean, one of the last things I guess I would throw out is, you know, it's almost like you have to go back to the code every time because it's an evolving issue. It's changing always, and it bothers me to no end. It's not my favorite thing I have to deal with as an architect, but it's nothing I can do anything about. It just is what it is. I could, you know, pound my fist on the table and I'm just going to have a sore fist. you got to just follow through and keep up with things. And again, that communication element is key.
Do you guys anticipate something coming down the pike here with MCM and Fire and issues in a way that is going to significantly change the approach?
What I would like to see happen within the industry is all the manufacturers just go to the fire-rated product, and gradually over time the delta between the cost of the PE core and the fire-rated core has been getting closer and closer over time. So hopefully at some point in the near future there's just a single core.
I would agree with that. That would help relieve confusion. I mean, maybe if the PE core just became an interior product, if it meets the interior fire criteria. The one thing that would be nice is if a lighter fire retardant core could be developed, because right now I think it's almost double the weight of the PE core. Still in a 4mm panel, it's not a significant change, but it is somewhat meaningful. It's something you just have to keep your mind on as a designer working on things.
Sure. And then, like for future education, there's also a white paper on the Metal Construction Association website of the difference between FR and PE, and kind of like a logic tree almost of around the code and when you would use what core in what situation.
All right, shall we move on to our next discussion, code requirements and energy issues, especially for energy. I do have a question from somebody here about two questions. I want to ask this one to keep in mind as you begin to address this. I have a question about wind pressure tests and when they're required, and how much does a thin panel develop much wind resistance. And I think you're going to talk about fastening in this section a little bit, so it seemed to me that was appropriate to bring up. But why don't we just jump into the energy one first?
Sure. Again, it's a code issue, so it's all about who your AHJ is and understanding what codes they require for your compliance for this energy criteria. There are a couple different codes that are in play. There's, the International Energy Conservation Code and ASHRAE 90.1. Understand what climate zones you're working in, because the requirements change, especially under ASHRAE, but I think also with the IECC. There's prescriptive and assembly-based requirements. Are you modeling this from a computer standpoint where you can do trade-offs, have a little bit less performance here and overall performance that meets the general? Those are things you have to figure out as your project develops. One thing to keep in mind is that the 2015 International Energy Code is going to include continuous installation in all wall assemblies across all climate zones. So from that standpoint, this continuous installation issue that we're going to talk about is going to become part of every conversation, and it affects how we put the MCM on a building. So do's and don'ts, again, you've got the foam plastic installation issues. Are you going to use mineral wool, or are you going to use a foam plastic? Go to section 2603 in your building code and figure out what's going to work best for your project. Zeke, do you have any thoughts?
Yeah, on the 2603, there's kind of a logic tree that, and it's something that's extremely, there's a lot of gray area with it now, because it is our interpretation that if there is a polyethylene core specification and it is going over a foam plastic insulation, that it automatically triggers you having to go to a fire retardant core as a result of that. If a project is NFPA 285, it has to be NFPA 285 compliant. It has to, and it's over polyiso, it has to go to a fire retardant core because there is no testing with a polyethylene core in a 285 situation. So that's like the most common misspecified item that we are seeing here of late. And if you're not working with the top shelf fabricators, if you will, they will miss that every single time.
Yep. I think that's really important. And, you know, again, those non-top shelf fabricators might not understand that NFPA 285 testing means you actually have to have a test of an assembly with all the layers and materials that you're looking at. It's not just kind of a, you know, blindfolded throw at a dartboard. It's a very specific test for a very specific assembly. And again, some places will allow for engineering judgments, but not every AHJ will. And they'll require to have a specific test that has, you know, your thermal barrier, your insulation, your weather barrier, you know, everything that you're showing in your detail. You can move to the next slide.
Yeah, yeah.
Which brings up an important kind of tie-in because, again, this diagram here speaks to what we'd call best practices and knowing what your different layers are in your wall. Industry-wide, they are frequently referred to as 4 control layers. You've got air, water, thermal, and vapor. There's the different zones in a wall where those particular elements are controlled. And like thermal is controlled by the insulation. Air and the vapor is usually controlled by a certain membrane. It could be a liquid applied, could be a sheet membrane. Sometimes that's also the water barrier. In the situation of a barrier system, MCM system, your water barrier and your air barrier is going to be the actual system, the MCM and the sealant. Now, that is something that we try not to promote that so much because you're relying on sealant, which has a lesser service life than, say, the MCM, and so you're inviting maintenance. When you're dealing with a back ventilated or a pressure equalized rain screen system, you're dealing with a system that's made to get water inside, it's made to not be perfect, and it's made to get the water out. And so, you know, there's certain logic to that. You know, when you get from the get-go, your sealant might not be perfectly installed, and you've got filtration. This other system gives you redundancy. It gives you ways for it to self-correct, whereas a barrier system does not. And so I know our office in particular would promote going with a rain screen type system. Now, that being said, each situation is going to be somewhat unique, and there might be places where a barrier system is more desirable, but that's something you'd have to kind of look at it on a case-by-case basis.
Yeah, Eric, on certain situations with rain screens, what we try to promote is like skyward joints be caulked in like a barrier system format.
Yeah.
So if you had coping caps, if you had possibly a large sill panel or something like that, we try to encourage them to caulk that, or on curved panel joints, because if you try to curve a rain screen joint, oftentimes aesthetically it isn't the best looking joint, and it's just hard to curve it and hard to get it right and get everything to engage properly. So we also encourage a barrier system in curved applications.
Yes. This diagram here also shows the whole wind criteria in a little graphic here, as you can see the fasteners. As architects, what we normally specify is our structural engineer is going to address the wind loading requirements on their drawings, or we include it on our drawings, so they supply it to us. for cladding loads. And then there's usually a delegated design aspect to our specification where the people who are doing the attachment system, or maybe the fabricator of the MCM themselves, has to hire a PE to validate, given the loading criteria that we have on our documents, that the assembly that's being put on and its attachment methodology, because we don't get into screw spacing and things like that, but obviously the installer does, they have to validate that that's going to meet the loading criteria.
Yeah, and when you're interviewing a potential fabricator, make sure that they have their testing for ASTM E330, which is the structural test that will.
Yes.
Usually that'll separate the men from the boys, so to speak.
Yep, and we include that as an informational submittal in our specifications also, that they have to show that they do in fact have that. But it's, as Zeke just pointed out, better to know in advance than you're in construction and, oops, we don't have that. So the next slide is continuous installation, and this has caused it's created a new architectural market. There are so many different new rain screen clip systems, it would be impossible to list them all. And they have a variety of different configurations. There's some that are these L-shaped systems where a T fits into. There's pultruded fiberglass. There's galvanized steel with fiberglass spacers. You think it, and you might have yourself a brand new continuous installation clip company. But the newness of these products gives us all kinds of problems because we don't know what their track record is. We just recently experienced one system which attaches its rails as part of the clip system all in one step, and because the area between the rails was sufficiently large enough, we needed to include impaling pins to hold the mineral wool insulation. With the rails in place and the impaling pins on the wall, it becomes really, really difficult, if not impossible, to fit the insulation tight against each other underneath the rails. And so it's not continuous insulation anymore when that happens. And so you got to understand how this stuff goes together and the sequencing. It's not something that architects want to learn yet a new thing. We will scream means and methods at a certain point, but also at some point you have to understand that what you've specified actually can go together. And if it can't, then the egg's kind of on your face as an architect. So it's important for us to do our research, understand how these things go together, so that when we're designing them and drawing them, that they can be built in the field.
Zeke, you want to weigh in on the continuous insulation and the attachments?
Sure, yeah. In the Southeast, we're probably the last guys to really get in on the ASHRAE 90.1 and all the different continuous insulation attachment systems, and oftentimes we still aren't seeing outboard insulation in our wall assemblies. So, but we're learning quickly on it, and Eric's right. If you can come up with the next great gizmo to make this work, you'll do okay in life, because there's a lot of momentum behind this right now, and justifiably so. And it is better to. We like to see it when the general contractor wants to put this in our package rather than separating it into two different scopes of work, meaning having possibly a drywall guy handle all the outboard insulation and the girts or whatnot behind it, because they seem to not take as great a care with it as the wall panel guy does. So it's definitely new for us, but we're fast learners.
I couldn't agree more. I mean, we've looked at it in a situation where we've even gone so far, because it's not just MCM, but there's other thin panels out there that can be installed with MCM on the same kind of clip system. We've gone to the point of creating a rain screen specification system so that from the air weather barrier out is all the same contractor's responsibility, and therefore you otherwise every time you get multiple contractors coming into one place, you get the finger pointing when things go wrong. Well, that was his. I thought he was going to do that. Oh, I thought he was going to do that. And next thing you know, you got trouble again. So I think Zeke is totally on it when he talks about making sure the Fabricator can follow through on that.
Guys, excellent timing. We are right here towards the end. I do have one quick question. This is really a specific question, if you got just a moment.
Sure.
One of the attendees is interested, and we were talking about fire-rated core to these things, on how you seal the corners on a fire-rated core. Is that just and I'm afraid I don't know enough to be able to say, well, that's a very proprietary answer or not?
Well, there's really no sealing that takes place. You're going to cut your panel to size. You're going to route the perimeter so you can fold your panels. And then if it's a barrier system like a wet joint or a route and return dry gasket, or specifically a wet caulk joint, that's going to be hidden behind the caulk. But some of the manufacturers at one time or another have raised some concern that the exposed flanges and the exposed cores were an issue, but I believe all manufacturers have since backed away from that, and it's not an issue for them. So in summary, there is no sealing of the corners that takes place.
Okay, excellent. Well, we're out of time, and Zeke and Eric, you guys are fabulous. Thank you so much for coming on and sharing your depth of knowledge with our attendees, and thank you all attendees for joining us and listening in today. We certainly appreciate it. And the final thank you to Firestone Building Products for making this possible for everybody. And thanks very much, and we will see you next time we do a webinar. Thanks. Bye.
Okay. Thank you all.
Thank you.